No, I was like, okay, what? I was trying to figure out what did I omit. I didn't think this one I omitted anything on. Here's 14C from the homework. It tells you that A is -2, -1, 1, 0, 3, -4, and B is 0, 3, 2, 0, -4, -1. Okay. Okay, so let's see, 2x plus 3a equals b. All right, so this particular semester when I am videoing this would be the fall of 25. So if you're in the fall of 25, this problem is assigned. If you're in future semesters, this is not one. You're welcome to look at it, but it may or may not be one that is assigned to you. So for those of you that are in the class that's the fall of 2025, you do have a homework set that was emailed to you or inboxed to you, so make sure to check that. You also have a list of suggested problems that was also inboxed to you just for my students for the fall of 2025. Okay, there's two different ways to work this one. You can actually solve this bottom equation for x and work it that way, just like a regular linear equation. Or you can set it up and do it where just in matrix forms. So you get to decide what works best for you. So for example, if I took this equation right here and I solve for x, I'm going to say 2x equals b minus 3a. And I can divide both sides by 2. So x would actually equal 1/2 of the matrix b minus 3a. Okay, so if you wanted to find the 3 by 2 matrix B minus 3A and then multiply all of the entries by 1/2, you can get your matrix that way. Okay, so that's a really good way to work it. You can also work it this way. You have 2 times x. Okay, so x is going to look something like that. Now you can use whatever letters you want to. Those are the ones I chose just because I don't know why, but that's why I chose them. Any letters you want to, you could do. So that's 2x plus 3 times a equals b. Okay? And so what we're looking for is to find the x, y, z, w, a, and b. So in order to do that, we can come up with 6 different itty-bitty equations. Now remember, I don't care which way you work it. If you think, hey, I think it'd just be easier to do this arithmetic with matrices here and then divide by 2, you're welcome to do it that way, or you can try it this way. Okay, so if I look at this one, in my x entry here, I'm going to have 2x minus 6 equals 0. Okay, so that's just the element 1, 1 all the way across. 2x minus 6 equals 0. So when I solve this out, I'm going to get that 2x equals 6, so x would equal 3. Okay, so I'm going to start putting them right here. X is 3. So then I'll do my next one, y. So 2y minus 3 would equal 3. 2y minus 3 equals 3. Okay, so 2y would equal 6, and y would equal 3. Okay, so then I can do my z one. 2z plus 3 equals 2. 2z plus 3 equals 2. Okay? 2z equals -1, so z equals -1/2. Okay, we can go ahead with w. 2w plus 0 equals 0. So 2w equals 0, so w equals 0. 2a plus 9 equals -4. So 2a equals -13, so a is -13/2. Okay, and when I'm working this one this particular way, I'm going to put my answers in there automatically, because if you put them in the wrong place, you're going to miss it, right? So make sure you put them in the proper place. Already did pink, let's do green. All right, and my last one would say 2b minus 12 equals negative 1. So 2b equals 11, and b would equal 11 halves. And that's how it looks. So this would be your matrix X. And again, you can work it this way. I probably think that this way is a little bit easier, but either way should work for you. Do you have any other questions in the homework or anything with 2122 so far? Excellent. All right. Here are some facts from section 2.3. This is not a full note part, so you'll still need your notebooks. It's just a couple of the theorems written out where I don't have to write them on the board. Okay, yay. Gotcha. All right, so in section 2.3, in math, let's put that there, section 2.3. That's what we're studying today. In a regular old equation, we say AX equals B, and we can divide both sides by A, and so we get our answer. Well, that doesn't work in a matrix. So if you had AX equals B, you can't divide by A. So the way that you get rid of A in order to get X by itself is you take the inverse. So remember, what you do to one side, you do to the other, but there's one more little caveat there. See how this red A inverse is on the left? Remember that the order that you multiply in is very important. So if you multiply on the left of the left, you have to also multiply by, on the right side, the left of that. Okay, so let me say that again, because that was a lot of lefts and rights. So let's take this off for a second. When you're working these matrix equations and you're trying to get the X by itself, you're going to multiply by the inverse, because multiplying by the inverse is like dividing, except we don't divide in matrices. So we're going to multiply over here, and A inverse times A would just cancel out and leave me with X. Okay, so we all know in math that what you do to one side, you do to the other. Okay, so I have to be careful. Of course, I'm going to put an A inverse on this side, but it matters which side of the B you put it on. So if I put it on the left side of this A, that means I also have to put it on the left side of this B, because this and this are not the same. Remember, matrix multiplication is not commutative, so they're not the same. So when you start working with these, just remember, if you're on the left side here, you have to be on the left side here as well. And of course, what you do to one side, you do to the other. Okay, so this whole section, 2.3, deals with inverses. An n by n, so here's your definition. An n by n matrix A is invertible. And we'll stop there for a second. There's a really important clause, actually a prepositional phrase, an n by n matrix. What does this mean?
The number of rows equals the number of columns.
Which
Is it a
square. Perfect. It has to be square. So you can't find the inverse of a matrix if it's not square. Okay. Rule number one. An n by n matrix A is invertible, which means non-singular. That's a definition I'll ask you a whole lot. which means non-singular. An n by n matrix A is invertible, which means non-singular, if there exists a matrix such that you have an n by n matrix B such that AB equals BA, which cancels out to give you the identity of that size. Now you actually write this there. They're real detailed with it. So it's IN, which means the identity of size n by n. Okay, so let me expand that just a little bit more. Hey, I do ask you definitions in this class, as you know, back from test 1. Singular is one of them. Okay, so this is actually really tricky, though, because it talks about invertible is non-singular and non-invertible is singular, so there's a lot of nons in there, right? And so you have to be really careful with it. So let me stack it over here on the side. Okay, invertible means it has an inverse. And if it has an inverse, it's called non-singular. Non-invertible means it does not have an inverse. And if it does not have an inverse, it is called singular. I'm going to double check them. I like it. Okay, so I think of it like single, which is not singular, but I think of it like single. If you're single, you don't have a partner at that time, okay? So singular means you do not have a partner at that time. So that's just one person. So there's no inverse. It's just the matrix. No inverse. But if it's not single, that means the matrix has an inverse. And so that's how I kind of keep it separate in my mind. The symbol for inverse is this. Notice that it's capital because it's a matrix. Okay, we're going to jump straight in. Okay. Now I'm going to work one problem, and I'm going to work it 3 different ways. Okay, the first way that I'm going to work it is a problem on your worksheet. It's not my favorite way to work it. It's not the quickest way to work it. But I want to show you how it kind of plays out. So that we're going to take, like I said, we're going to take this problem. We're going to work it 3 ways. Here's method 1. The way that you can find the inverse is this. Remember you had a rule on the previous page, the definition actually, that said A times B equals I. Okay, so let's write that out for just a second. 1, -2, 3, -1. It says you have an inverse if there is a B matrix such that A times B equals I. Okay, so I know my I matrix for 2 by 2 looks like this. I just don't know B. Okay? So we're going to come up with an equation that looks like this. You'll say, well, I don't know. We know that B is 2 by 2, right? It's got to be 2 by 2 because if I started with a 2 by 2 here, I know that this has to be a 2 because in order to multiply them, those have to be alike. And I know that this has to be a 2 right here because my product at the end is also a 2 by 2. So that's how I know that B has to be 2 by 2. Okay? Now, I don't know what B looks like, so I'm going to give it letters, kind of like we did earlier in the problem before. So I'm going to call it A, B, C, D. You could call it X, Y, Z, Q if you wanted to, however you wanted to label it. Okay, and again, this is the hard way. We're going to do one in a minute that takes like 2 steps. Okay, but on your worksheet, there's one that looks like this. You can practice it. It's not my favorite, so I doubt that it's tested. Remember, when you multiply matrices, you go across the first matrix and down the second. So when I do this, it's going to look like this. So I'm going to say 1A minus 2C. Okay, so I'm going to point at it. 1A minus 2C. Okay, and that's what's going to go in that blank. All right, let's go row 1, column 2. Okay, so that would be 1 times B minus 2D. 1 times B minus 2D. That's how that would look. Are there any questions with how we got those? Okay, now we're going to do row 2, column 1. So that's going to be 3A minus C. And row 2, column 2 is going to be 3B minus D. Now remember, that's my product. That has to equal 1001. Now, let's get out of matrix land for a second. In order for 2 matrices to be equal, their corresponding parts have to be equal. So A minus 2C has to equal 1. And on the bottom, 3A minus C has to equal 0. And I'm going to put those 2 blue ones together because they have the same letters. Okay, I'm going to look at the other column. The other column says B minus 2D equals 0. And 3B minus D equals 1. So what we do with it at this point is go back to our earlier studies, back from test 1, and solve these systems of equations. Do you have any question with how we got that part? Okay, so I'm going to solve it. You know me, my favorite way is elimination by addition. But if you wanted to solve it by substitution, you certainly could do that. So if I'm using elimination by addition, I'm going to multiply this top row by negative 3. Negative 3A plus 6C equals negative 3. Negative 3A plus 6C equals negative 3. And if I add these up, I get 5C equals negative 3. So C is negative 3/5. And you're like, oh, goodness, you gave us fractions. Well, keep in mind what we're doing here. We're finding the inverse, and the inverse is kind of like dividing, right? So you may have some, or you will have some fractions in that. Right, so that is my first value. You'll say, well, how do you find the second value? You can do it again and eliminate the C if you want to. Or you can take that blue negative 3/5 there and plug it in. Okay, so I'm going to plug it in to this bottom equation to back substitute. You can do either equation though. So I'm going to say 3A minus, there's my minus, a negative 3/5 equals 0. So this is 3A plus 3/5 equals 0. So 3A would equal a negative 3/5. I'm going to divide by 3. And when I divide by 3, going old school, I get negative 1/5. Now make sure I put it in the right place. That's where it would go. Let's clean it up a little. It doesn't look right. Yep.
Is it the case of like the negative 1/5 and the negative 3/5? That's supposed to be what A and C are equal, not what 1A minus 2C and
This is where I'm going with it.
Uh,
I did put it in the wrong, at that point in time, that was all that was left on my page. So let me erase it. I didn't have enough room. And I can't write it over here because nobody can see it on the that's taking it virtually. Where should I write it?
that, as that matrix, that's supposed to be a times a to the negative first power, not a to the negative first power. I guess what consists of a minus 2c, 3a minus c, I guess.
No, if you multiply these two things together, that product, AB, is that matrix. Is that working? Does that make sense? So when I'm finding these values, this is my A and this is my C. So this is where I'm trying to go. I'm trying to find this. This is my answer right here. This is my answer. So as soon as I got my A is negative 1/5 and my B is negative 3/5. Okay. So now then we'll do the green part. And so we'll get rid of that one. So we'll say that this is a negative 3. So I get negative 3b plus 6d equals 0. Okay, so I add those up, and I get 5d equals 1. So that means d equals 1/5. Okay, so d in this matrix right here, d goes right here. Okay, so we plug back in. B minus 2 times D equals 0. So B minus 2/5 equals 0. So B would equal 2/5. So in this particular problem, I'm looking for the B matrix that would cancel out the A matrix to give it the identity. So your B matrix up here is negative 1/5, 2/5, negative 3/5, 1/5, which you could call B, or you could call it A inverse, because you have successfully found the inverse of that matrix. Now, that's like you see number, it's one way of finding it, right? That is just like number 11 on your worksheet. Okay, but that is not the easiest way to work it. Are there any, did that help you? Does that help show where we're going?
I confused the matrix that you said equal to the identity matrix for the inverse matrix.
Gotcha.
That's what I was trying
Okay.
to say. Yeah.
Gotcha.
So yeah, I apologize.
Oh, no, you're fine. You're fine. Always ask. All right, so that's the first one. Now we're going to do it a second way. We're going to get that green answer every time. We're doing it the same problem 3 times. So here's the second way. Find the inverse. Okay, I also don't want you to work it this way. And you're like, why on earth are you telling us how to work these if these aren't the way you're going to do it? So this way right here is long and lengthy, and it's not fun at all, and it uses Gauss-Jordan. Oh, no, it uses Gauss-Jordan. It doesn't even use Gaussian. It goes all the way with Gauss-Jordan, and we're like, right? And so that's why this one's harder. You'll say, well, then why are you doing it, Ms. Cannon? So the reason that I'm doing it is that's the only way to work a 3x3. So I need to show you how to do it with a 2x2 on the easier side. Not easy, but easier side before we can do the 3x3, which we'll do on Monday. Okay, so here's how it looks. You've got your matrix. I'm going to put some dotted lines down this way. You're going to adjoin, it's called adjoining, A-D-J-O-I-N. You're going to adjoin this matrix A with the identity. Okay, that's how it's going to look. So basically, it looks like this. You have A adjoined with the identity. Now what happens is you're going to manipulate this A. Okay, so what I mean by that is we're going to get rid of the 1. The 1's fine. Sorry, we're going to leave that 1 alone. We're going to get rid of the 3. We're going to get a 1 right here in this position, and then we're going to get a 0 here. So it's going to be 1, 0, 1, 0, right? Which turns it into the identity. So we'll do that by using our elementary row operations from our last class. So when we do that, we're going to go all the way across that matrix, that adjoined matrix, and what I get on this side will be your inverse. Okay? So here we go. Let's see if I can get those red. There we go. No, I can't. The first thing I'm going to do is get rid of the 3. So I'm going to say negative 3 row 1 plus row 2 gives me a new row 2. I'm going to get rid of this guy right here. So that's negative 3, 6, negative 3, 0. You go all the way across. Negative 3, 6, negative 3, 0. So we get 0, 5, negative 3, 1. The top row stays the same. And that's what the bottom row looks like. So now my first column looks great. The first column is in row echelon form. Okay, so now we got to go to the second column and knock it out. I need to get rid of this guy. So to get rid of this guy, I'm going to say 1/5 row 2 gives me a new row 2. Welcome to fraction land. So now I got that as a 1. So that looks good too. So now we're in row echelon form, but I need it to be in reduced row echelon form, which means I need to get rid of the 2. With fractions. Sorry about that. You are going to have, if you do it this way, you are going to have fractions. So you're going to say positive 2, positive 2 row 2. Add that to row 1, and that's going to give you a new row 1. Okay, so that's how it looks when I multiply that whole bottom row by 2. Because, of course, it's 2 over 1, so you're just multiplying by 2 on the top. Okay, so I get 1 and 0. So that's negative 6/5 plus 1. Well, 1 is 5/5. So negative 6/5 plus 5/5 is a negative 1/5, 2/5. Okay? Now, look back over here where I told what was happening. You took A and you did elementary operation, elementary operation, elementary operation until it ended up with the identity on the left. When you get the identity on the left, what you get on the right is your index. Index is your inverse, sorry. And that's your inverse. Still the long way. Still not the way I want you to do it on the test. However, you'll have a 3 by 3. And so you see on this one that we used it 1, 2, we did 3 operations. So on a 3 by 3, you might do as many as 9. Whew, that's a rough one. Any questions with this one? So finally, we get to the way I want you to work it. Oh, they're much easier. Let's see. There, it's all over 5. Yes, we're going to do something over 5. Right, there's a formula. I don't ever use the formula anymore, and you won't by the time you do it either. There it is. Here is the formal formula. That is the determinant formula. Look at you. Absolutely. So that is your determinant formula. He is exactly right. Now, when we get to chapter 3, which is not this test, but the next one, when you get to chapter 3, the whole thing's about the determinants. You get a whole chapter on the determinant. I think, something like that. All right. Yeah, it's a C. Let me keep tipping. It'll come back. There it goes. The board says it's given up today. All right, so this is the easy way. So what this number is, AD minus BC, is going to be a big deal for us later on, so let's go ahead and talk about it. This is called the determinant, and the way that you find the determinant is this. You multiply your main diagonal, AD, minus your secondary diagonal, BC. So over here, my determinant, the symbol for the determinant is this, by the way. I didn't talk about it much. It looks like it's absolute value, but it's not absolute value in this context. In this context, that's your symbol for determinant. You can also use the determinant as DET. Okay, that's also the determinant. So the way that you find the determinant is you're going to take this primary diagonal right here, which is multiply that, and you get -1, minus, because minus is what's in the formula, your secondary diagonal. Watch your sign. The secondary diagonal is -6. Okay, so -1 plus 6 would give me 5 as the determinant. Okay, so that's how we're going to start this one, finding that inverse. So A inverse is 1 over 5. Hence the 1/5 we got all the time, right? That's where the 5 is going to come from. Now, you'll say, oh, what is this other? What did you do? So on the other one, I don't memorize the formula because that doesn't work for me. What this formula tells you to do is a procedure. And in that procedure, it tells you to swap the primary diagonal. So this 1 right here is now going to go here. And this -1 right here is going to go here. Now, it looks like I changed the sign of it, but that's not what I did. It's just that's how it worked out in this particular example. I actually switched their places. So the -1 went to the top corner, and the other one went to the bottom corner. Now, the secondary diagonal, you do change the sign. So instead of a -2, it's going to be a +2 and a -3. So this group, you change the sign. This group, you change their position, swap position. Okay, and so we'll clean it up. A inverse equals -1/5, 2/5, -3/5, 1/5. Bingo, super fast. Now then, I'm going to give you a trick one because I need to talk about the trick, and then I'm going to give you one to grow on, so kind of. Oh. Should work from the other day. There it is. Perfect. Let me give you a trick one. B.
I see. You get a divisor of 0.
You get a divisor of 0. When we take the determinant here, we get 6 minus 2 negatives make a positive 6. And I can stop there. I get 1 over 0. Okay, so if you get 1 over 0, it's undefined. So this has no inverse. And the reason it has no inverse is because the determinant equals 0. So anytime you have a determinant of 0, that means it's going to be a singular matrix. Okay? Now, I need you to do one because it's going to go back to something we did in section 2.2 or lead into something. The other day, you're like, why did we have to write this? But the other day, I gave you an equation, a system, that was 2x plus 3y equals 5 and x plus 4y equals 10. So the coefficient matrix, and you have this back on your handout from the other day, the coefficient matrix looked like this. Let's call it C because we haven't gotten to there today. So what I want you to do between now and Monday, besides your homework set, right, is I want you to find the inverse of C. This one has one. So find the inverse of C for me, and we're going to build off of that next time. Okay, so remember to do your homework. Turn that into me on Monday. If you have any questions as you work on it, just let me know. Send me an email this weekend. I'll be glad to help. I'll also be here Thursday and Friday of this week, should you need me.